All right, guys, so this is the second day that the Teach Piece is online. I will upload this to, as you can tell, I have uploaded this to Edpuzzle, so I will be able to tell who did watch it. But let's go ahead and get started. You have the assignments that are all in Big Ideas over these last 2 days. They will all be due when I return, so please make sure that the ones you can do are done, and we can talk about what you don't understand when I get back. But you need to get done as much as you can because we only have a limited amount of time before Thanksgiving break, okay? All right, so the important information from Cpctc. So remember, and I'm going to type this just because, make sure. All right, so Cpctc stands for corresponding parts of congruent triangles are congruent, meaning if the triangles are congruent, and I'm going to change the size of this, then all their parts are also congruent. All right, so let's make that a doable size, and let's make it a better color. All right. So corresponding parts of congruent triangles are congruent, meaning if the triangles are congruent, then all their parts are also congruent. Another important thing that you need to make sure that we are good on is Cpctc can only be used in a proof after the triangles are proved congruent, meaning you have to use side, 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 angle, sides, angle, angle, side, or angle, side, angle, or hypotenuse, leg. You have to use first. So those are the two main things. All right, so let's just do some examples. So here's all your steps, same as before. All right, proof number 1. So proof number 1, and I have not done these yet, so let's hope we don't mess up. All right, let's see. Given that A is the midpoint of Rn, so if A is the middle of Rn, so this is given, and I will change the thickness there so we can read it. All right, so if this is the middle, I immediately know that those two things are equal to each other because that is the definition of a midpoint. That is the definition of a midpoint. So always remember, if they tell you something's a midpoint, your very next reason is going to be definition of a midpoint. You just have to show me which two things. Now, RG is equal to NG. RG is equal to NG. That is also given. AG is equal to itself. That's reflexive. All right, so now I can prove that this triangle, GRA, is congruent to this triangle, GNA, by side, side, side. Now they want me to prove that these two angles are congruent. So they're saying, hey, can you prove that angle ARG, they want me to prove that this angle and ANG and this angle are congruent. Well, if this triangle is equal to this triangle, then all of their parts are equal. So Cpctc is your reason there. Notice I had to use this first. All right, let's take a look at another one. Proof number 2. JL, so this segment right here, it is bisecting angle KJM. So that means that this angle is equal to this angle because it is an angle bisector, okay? So this is given. Angle K is congruent to angle M. So angle K is congruent to angle M. That's also given. And, oh wait, that's not where that goes. this goes here. K is equal to J. So KJL, so this is definition of an angle bisector. Sorry, that was, I told you I haven't done this yet. Definition of an angle bisector. All right, so let me scroll up just a smidge here. Okay, JL equals JL. Well, the only reason something ever equals itself is the reflexive property. All right, and this triangle up here, so LKJ is congruent to LMJ by angle, side, angle, side. Now they want me to prove that this piece is congruent to this piece. So they want me to prove that KL is congruent to LM. Well, if the two triangles are identical, then all of their parts are also identical. So this is Cpctc. Notice that was first. So anytime they want you to prove two pieces are equal to each other, more than likely, it's going to be the last thing. All right, number 3. Don't forget, if I'm going too fast, I'm trying to keep the video short. You can always push pause if you need time to write. You do not have to stay at the same speed as me. All right, given segment SY is congruent to KE, so that's given. KE, I'm going to change the color here. KE is parallel to SY, so this is parallel to SY, so this is also given. Now, since these two pieces here, since this is parallel to this is going to be my transversal, meaning that angle 2 is congruent to angle 3 because they are alternate interior angles. So alternate, can't spell, interior angles. I hope that shows up good for y'all. It shows up good on my end. Now, segment KY is congruent to segment KY. Well, this is equal to itself by the reflexive property. That one should be one of those easy ones, kind of like given. So now, KEY, so triangle KEY. So triangle KEY. So I'm going to look at what information, what 3 pieces do I know? I know that this side, I know this angle, and I know this side. This is side, angle, side. So these two triangles are congruent by side, angle, side. And therefore, I can prove that angle 1 is congruent to angle 4. So now, if the triangles are congruent, I know that these two angles are congruent because if the triangles are congruent, all their parts are congruent. So Cpctc. And I learned in chapter 3 that if alternate interior angles were congruent, then the lines that they're between are parallel. So this is going to be because of alternate interior angles. And this is the converse theorem. All right, I'm just going to abbreviate that, okay? Just as long as you know, the important thing to me is as long as you know that if these two angles are equal, these two sides are parallel. And then, obviously, if these are parallel, then these are congruent. So that one goes forward and backwards. But my main thing is if you recognize those alternate interior angles are congruent, I am totally fine with that. All right, number 4. Given segment JL, so segment JL, so this is a L. I accidentally cut it off when I screenshot. I apologize. Bisects angle KLM, so that means this angle is equal to this angle. So this is given. Okay, KM is congruent, so KM is congruent to ML, that's given. JL bisects, that's also given. And because this bisects, this angle is equal to this angle, So that is the definition of an angle bisector. JL is equal to itself. That's always reflexive when you equal yourself. And now I know that triangle JKL is congruent to triangle JML by side angle side, because I have this side, this angle, and this side. So this is side angle side. Therefore, if the two triangles are congruent, now I know triangle KJL and LJM in this angle here. So now I know that these two angles are congruent by Cpctc, because if the triangles are congruent, all their parts are congruent. So that means that this is not only the angle bisector of what they told me, now I know it's the angle bisector of the other part. I think I did this backwards. Bisects. No, I didn't. So it does, but okay. So this is going to be the definition of an angle bisector. See, y'all aren't the only one that get tripped up over all these letters. It's very easy to do. So please don't discard yourself or think that you can't do it, because it's easy to get confused. So now I know that it said that this was an angle bisector of this, and I proved it was also the angle bisector of that. As long as you have equal angles, then you know that is cutting it in half. All right, I think. All right, so incomplete sentences explain the steps of working a two-column proof. So the steps of working a two-column proof. First, determine what is given. Okay, that is very first thing, determine what is given. Then mark your diagram with appropriate tick marks. So mark your segments congruent, mark your angles congruent, mark your sides parallel, whatever it is you got to do. Then determine what you know from what the hidden information, and mark the diagram. So your vertical angles, your alternate interior angles, what are the other things? The reflexive, things like that, okay? You always want to look for your hidden. Once you have all the markings, you should be able to determine which congruence theorem is needed to prove your triangles are congruent. Then, if needed, you can prove parts are congruent using Cpctc. So first and utmost, determine what's given, mark it. Determine what's hidden, mark it. From that information, you should be good, and you should be able to write your proof. All right, I think that's it. All right, the end. Please, guys, make sure that you take care of the assignment that I've left for you, and if you have questions, I will answer them when I get back. But please make sure you work on what you can and do everything that you are capable of doing. Work together and help each other and make good choices. I will see you guys when I get back. Bye.